middle of it. We need to be on the other curve, which has 62 in the middle of it.
70.2.
There we go. There we, and Big Mike's answered the question for us. So I'm going to mute this. We now know that. Oops, that's a little too far. What's the matter?
Nothing.
Okay. We now know we're 1.64 standard deviations up. So all we've got to do is go up 1.64 standard deviations and up on this curve. So we know that one standard deviation is 5 miles an hour. We've got to go 0.64 more than that, roughly 2/3 of that. So now the formulas you'll have on the board, we're going to use both of them as of today. The forward one, you'll definitely have this one on the board for you. And the backward one is this one. Now, yes, they're the same formula, it's just what's on one side by itself. Theoretically speaking, friends, in order to answer part A, we'd have to have this, don't write this down, we'd have to have this formula on the board. That's what we would have had to done earlier to answer part A, solve for sigma. But that's just silly. I mean, it's cool, but it's like a math problem. It's not a stat problem, it's a math problem. We made it a stat problem by eyeballing where it was. I like that much better. So, anyway, here's your backwards. Now, memorizing why it's backwards isn't important either. Just realize what you're looking for. You're looking for this, which is a speed. Speed in miles per hour, z-score. And you've got all these pieces now, don't you? You've got the average speed of 62. You know you've got to go out 1.64 standard deviations. And one standard deviation is 5 miles an hour. So you just plug and chug at this point. 62 plus 1.64 standard deviations times 5, 7.8, yeah, 70 miles an hour, is that what you're saying, Big Mike? 70.2, we'll call it about 70. 70 miles per hour, friends. Roughly, this is kind of a cool figure to have. We know that 8% of people are going less than 55, and we know that 95% of them are going less than 70. Which means we can actually put one more figure in there, couldn't we? What percent are going between 55 and 70? 87. Whatever the difference is, right? 87. 95 minus the 8. Boom, 87. Yeah. So that's again, good to know. Good to know. A sizable chunk are going between 55 and 70. And once you know the average and the standard deviation, the entire distribution is determined. You get it where you need to be. It's pretty rad. Pretty rad. I think it's pretty rad. It's pretty sweet, pretty useful. Using good health, I'm saying. Decent? Beth, makes sense?
Yeah.
Thank you for those questions. It was great. Everyone you guys asked for was one that other classes didn't ask for. That's fantastic. Anything else? Jesse, you got us a central limit theorem question. That was awesome earlier. Yes? That was good. The E questions in that section okay? Central limit theorem E questions? We got time to want to bang one out real quick? They're fairly quick. Let's talk through a couple of them. This will help you with the take-home part of the exam, and I'll give you a hint as to what the in-class central limit theorem question will look like, because we just learned that this week. And what's that? No, go ahead.
No. I think carry on.
No. You'll like this. You'll like this because the one I'll put on the in-class is really, really straightforward. I basically want to give everybody that 10 or 20 points on that. I want you to get them all and nail them. So let's just talk about it. I want to. I just want you to pay attention to understand what I'm asking you. So I do. I love when you guys do all these things. It makes me happy. So here, these are some of my favorite. You can't see that. Why can't you see that? It's not on blank. Okay. No, it's not on blank. So we did one of those earlier, right? I think we did one of those, right, Jessica? One of those guys up there. Let's look at this one right here.
Yeah.
Okay. I poached these graphics from Monty Cheney's old notes. I was going to make it myself. I'm like, what the hell? You're doing it for me. Perfect. That is a distribution of some random variable, and I don't know what it is. It's already bell-shaped. That's the population. So if you're looking for an analogy to class, remember when I had you guys draw out the distributions of your dice? Right, that's what you'd be looking at. So that would be the orange graph, or the green graph, or the blue graph, or the red graph, or the yellow graph.
Okay.
I'm asking you, which of those graphs below show a sampling distribution of size 5, 10, or 30?
Please put this one on the Yeah.
Okay,
Yeah.
done.
Use it.
So what I'm saying is we understand this one, right?
20 points.
Sample of size 5.
B.
B.
Sample of size 10.
A.
Sample of size 30.
C.
Okay, we're happy. Good. All right, let's go.
I love Central and too.
What's not the love? Charlie, what is not the love? I've been slacking on the names, I apologize. E2. E2, you got a skewed distribution. For starters, skewed distribution. But the problem is you're never going to know that because you're drawing a sample. You don't know what the shape of the distribution is necessarily. Sample of size 5.
A.
Say that wasn't as confident as the last one. Sample of size 5.
A.
Sample of size 10.
B.
Sample of size, whatever's left, 30.
B.
Good. I think what happened, the confidence,
That's outliers.
right. If you had outliers, so it takes a little bit longer to get it into that bell shape. But the kicker is too, don't just look at the narrowness, look at the height.
Yeah.
Right, the height. They get taller as they get narrower.
Right.
Remind me again why they get taller as they get narrower.
Because they're not covering as much area, not much probability.
How much area is under the curve? Always. Always. Percentage-wise.
Yeah.
It's kind of a silly question. How much area, if I colored this is a dumb question, I would ask it anyway. If I colored the entire curve, what percent would I have colored? Sorry, it's 100%. I was trying to, as soon as I started asking, I'm like, this is a dumb question. They know what it's always, the sum of all the areas under the curve is always 100%.
Right.
So if you shove the curve in this way, you don't lose that 100%. It has to go somewhere. It can't go down and become negative. So the middle has to go up to make up for that. Does that make sense?
Yeah.
That's why they get taller while they also get narrower. Yes? Good. Another one?
Sure.
I don't know, man.
Uniform distribution?
Yeah.
You'll see this one on your take home as well. The Excel distribution is uniform. You don't need to know that, but it's in
Yeah,
there.
easily. What?
I'm saying you don't need to know that it's called uniform.
Oh.
It just is uniform.
Okay.
Because of the way I'm randomly generating numbers between something and something, which is automatically uniform distribution. It's like rolling a dice with 6 sides, 10 sides, 12 sides, 20 sides. I think it's 16 sides in your exam. So sample size 5.
B.
Sample of size 10.
C.
Sample of size 30.
A.
Nailing it.
Were you going to say sample size of A?
I don't know what I was going to say. I say a lot of things. You want to do one? Please swing with 2 bats.
Yeah.
Swing with 2 bats.
Oh, no, put it back.
Swing with 2 bats. There's your original distribution. That's the actual probability distribution. Notice the difference in symbols. Average versus the actual number. Just like you guys on your quiz that you did on Tuesday. No. Monday.
Okay.
You were graphing averages on your sampling distribution that were drawn from a population with values. Okay. So, sample of size 5.
C. What? C. No, Tabitha. That's A. Oh.
Remember, what happens to the curve? Pretend there's curves on these. What happens to the curves? They get less variation, which means they get skinnier. Which of those 3 sample distributions is the widest? A is the widest. That means that has to be the sample of size 5. How can you tell it's the widest? There's no graph.
Because
There's four sets of numbers in B2.
They're bigger. Yeah, but they're bigger on the
Good. Now you're talking, friends. They're bigger in A on the outside. See the outside? 6%, 6.5%, 4.5%. These tails are skinnier, which means that A is like this, or B is like this. Right? Sample of size 5. Sample of size 10.
B.
Sample of size 30.
B.
Done and done. There you go. Perfect. So you don't even have to have the curve distribution. I promise to give you the curves. Because they're more obvious. And plus you seem to like those more. Yeah?
They're way more fun.
They're way more fun. Well, I like fun. I like it also when fun intersects with usefulness, which I think this just did. So, this was great. You guys asked for totally different questions in the other class. This is fantastic. There are now roughly 2 hours maybe down to an hour and a half once I cut out all the banter in between.
We have like,
Of useful, I won't cut it out.
we have like 10 minutes.
I meant my stupid stories. What that?
What is the question we should have asked that we didn't?
Oh, I don't know. You guys pretty much
Oh, you
covered.
do too, you know.
Hang on, let me think. I didn't make your in-class exam yet.
What's something that we should probably go over?
Okay, let me give you a heads up. You covered. Let me think about this. We covered. I'm thinking of your out-of-class exam right now. I haven't written your in-class exam yet. I'm working on it. I'm in the process of working on it.
Procrastination.
You, it's called advisees who didn't register early enough, and now it's my problem. But these stories I hear, I don't know what's crap and what's real, and I always feel bad. I'm like, I'm Italian. My car had 4 flats. Oh God, that's awful. Statistician. No, he didn't have 4 flats.
Yeah.
Great story. I don't know if it's true or not. Great story. Speaking of that, there was a stat professor. I hope this story's true. I heard it years ago. 4 kids missed the final exam. 4 kids missed the final exam, stat exam. And they all came to the prof after the exam. Or after the exam was over, there's like, we completely missed the exam. We were carpooling together from a great distance away. We got a flat tire on the way into the exam. And by the time we got the tire fixed, we couldn't get into the exam on time. What could we do? He's like, staff professor's like, no problem. Get a makeup. We'll get you makeup. No problem. So he puts them in 4 separate rooms with the exam.
Which tire?
Turns the exam over. 100 points. First question, which tire? Which tire? Awesome. Awesome. Then it's fun figuring out what's the chance they all guess the right one. I love that. Anyway, you guys, I believe it's 1 in 16. I believe. Anyway, you guys covered about a third of the take-home with your Bishop showerhead problem from class, whatever it was yesterday. There's a Northwest Airlines problem on your take-home exam that's almost identical. Almost identical. There's another question on your take-home, a series of questions about salmonella in chickens.
Yes.
We covered a problem in the 1015 class on E. coli testing in combined samples. So on the videos for the earlier class, we did a nice analysis of that, which is congruent to the question I'm asking you on that. So that you guys covered that as well. The central limit theorem questions you just asked, you essentially covered all of what's on that for the take-home too. So you pretty much covered the take-home with the questions that they asked and you asked today and Monday. So you're golden there. I'll build the rest of the exam around the kind of questions you guys asked as well. The in-class exam, I'll build them around the ones you guys were asking because you asked really, really good ones. I mean, I was thinking about those are the kinds of questions. Like I want to use Max. I want to use his head girth or something like that because we seem to like having Max in class. And he's still cute enough size I can do that without embarrassing him too bad. So I'll keep it congruent with what you guys are asking. Because, the questions you guys are asking are the ones I would have assessed you on anyway. So why not just keep it with the ones we just practiced? So, cool?
I'm sorry for your sibling of puberty and growth rates.
Nah. Well, it'll be more fun.
Oh my gosh.
It'll be even more fun for me.
Chances
For me, poor Max.